Homework answers. Here is my circular graph drawn out. And notice that car 1 is at 0 degrees, car 2 is at 72 degrees, and car 3 is 144 degrees, car 4 is 216, and car 5 is 288 degrees. Okay, then we had to find the height of each one. Well, if the height of the Ferris wheel is 150, that only makes sense that the car 1, which is directly in the middle, is 75. Here is the triangle for car 2. It's going to be sine 72 degrees equals x over 75. Solve it for x, and you come back with a value that you must add to 75 in order to get 146.33. Over here on car 3, it's a 36 degree angle in here because it is between 180 and 144, 36 degrees. Sine 36 degrees equals x, which is this, over 75. Solve and get this value and add it to the 75 feet, 119.08. We are rounding all these to the hundredths place. Car 4, luckily enough, it has the same degree measurement, 36. That's between 180 and 216. So sine of 36 degrees equals x over 75. You get the same value, only this time you're going down on the Ferris wheel, so you must subtract this value from 75, like we did here, and get 30.92. And then over here to car 5, we end up with a degree measurement of 72. Of course, my freehand circular drawings are not the greatest when it comes to spokes, so you notice it should have been the same on those. But anyway, it is still 71.33 feet for that x value, but you have to subtract it from 75 like we did here to get 3.67. And then part B. Part B was 75 feet because we had to make 2/5 of a rotation for car 4. So here's car 4. There is 1/5 of a rotation. Here is 2/5 of a rotation. The height that it ends up at is 75 feet. Here is the graph in relation to car 1 starting at 75 feet and going around at least 4 rotations. So if you plot all the numbers that we had with no rotation, you end up here. Yesterday on this graph that I made in class that I put on the video, I believe I started car 1. I think it was 50 feet yesterday. I think I put it right here instead of putting it on the 0. So if you made that mistake along with me because I made it, then you might want to remember that. Notice that since it's at no rotations here, it's got to start there on the y-axis. So that's recorded forever for posterity. The people, some of my fans in China can send me comments over YouTube and stuff. So we'll go here and then plot the next one as it goes up and then back down. It's just a matter of plotting the points and connecting the dots, but remember these should be curves up here. And when you get down to the bottom, you should be at 0. I'm missing 0 just by a little bit. And the height is 150, so you should be touching up there. It's got to be a curve. It's not a pointed V shape when you make the turnaround. As a reminder, your objectives are graph functions expressed symbolically and show key features of the graph by hand in simple cases using technology for more complicated cases. Graph exponential and logarithmic functions showing intercepts and end behavior, and trigonometric functions showing period, midline, and amplitude. We're still yet to get to that part. We're still practicing the first stuff. Understand radian measure of an angle as the length of the arc on the unit circle subtended by the angle. We will do something with this today. We will take a look at a radian circle graph. And then the last objective, explain how the unit circle in the coordinate plane enables the extension of trigonometric functions to all real numbers, interpreted as radian measures of angles traversed counterclockwise around the unit circle. We are going to fill this in with radian measures. If you can remember the basic ones, in radians, over here, it's 0 degrees, and in radians, that will always be 0 as well when you're starting out. It can also be something else if you go around the circle multiple times. The next easiest one is 90 degrees. It's pi over 2. And 180 is simply pi. So notice you have 90 degrees is 1/2 pi and 180 degrees is pi. So if you go around the circle just a half time, you've gone 1 pi. If you go 90 degrees, it's a 1/2 pi. Every 90 degrees you're adding 1/2 to the pi. So if I'm adding 1/2 because I'm going 90 degrees from here to there, 1 plus a 1/2 is how much? 1 1/2, we express it as an improper fraction. What is 1 1/2 as an improper fraction? 3 over 2. 3 pi over 2. If you go all the way around the circle, remember when you went 180 degrees it was pi. If you go another 180 degrees back to 0, how much is it? 180 degrees is pi. If I add another 180 degrees to that, how many pi's do I have? 2, yes. So it would be also 2 pi. Now we're just doing one rotation. So we're going to go back and fill this in. I need a laser pointer that's a little better. There we go. Notice what we have here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 markings to get to 1 pi. So this half circle is divided into how many pieces? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many pieces is the half circle divided into? 12. Therefore, if we start out over here at this marking, this would be pi over 12. If we go up to the next marking, the one before it was 1 pi over 12, so this one should be 2 pi over 12, but you reduce the fraction, so it's pi over 6. The next marking is 3 pi over 12. Reduce the fraction, it is pi over 4. The next marking is 4 pi over 12. Reduce the fraction, it is pi over 3. The next marking is 5 pi over 12. And you cannot reduce that. If I break 180 degrees up into 15 pieces, what are these degree markings going to be? For example, what is this? Any idea what degree marking this is? 45. So if that is 45 degrees, then what is the one below it? If we have 2 more marks to go to get to 0. 3 marks is 45, so it's been divided up into how many degrees? It'll be 30 because it's been divided up into 15. Radian measure on top, degrees on bottom. If we go to the other side and fill in our degrees, you'll have 105, 120, 135, 150, and 165. You can go back and do the radian measure now. What unreduced fraction did we end up with up here? Not pi over 2. What's the unreduced fraction with a denominator of 12? This is 5 pi over 12. We're ending here. It was already finished for us. Pi over 12 with a denominator, or a pi over 2 with a denominator of 12. Can you change pi over 2 to a fraction with a denominator of 12? What denominator is this? And we're going to 12. What do I multiply 2 by to get 12? So that would be 6 pi over 12 there. If this is 6 pi over 12, what is the next one? 7 pi over 12. The next one is 8 pi over 12, but you have to reduce it. 2 pi over 3. The next one is 9 pi over 12, but you have to reduce it. 3 pi over 4. The next one is 10 pi over 12, but you must reduce it. What is 10 pi over 12 reduced? 5 pi over 6. The next one is 11 pi over 12. Can I reduce that? There's half of your unit circle. We finished with what unreduced fraction here? 12 pi over 12, that's right. So now we can go to 13 pi over 12. The next one is 14 pi over 12. 14 pi over 12 reduced. 7 pi over 6. 15 pi over 12 is next. What is that reduced? 5 pi over 3. Is that right? Yeah, 5 pi over 4. Don't forget you're adding 15 degrees each time. So 195, 210, 225, 240, and this one right here, which is kind of squeezed out, is going to be 255. Alright, so we did 15 pi over 12. The next one is 16 pi over 12. What's that reduced? 4 pi over 3. And then the last one is 17 pi over 12. Can we reduce that? Nope. Alright, here we are. We have one more quadrant to go. We will fill in our degrees first. That should be 285, 300, 315, 330, 345. And we finished with what unreduced fraction here? 18 pi over 12. Yes, so the next one is 19 pi over 12. It cannot be reduced. The next one is 20 pi over 12. That can be reduced to 5 pi over 3. The next one is 21 pi over 12. That can be reduced to 7 pi over 3. The next one is 22 pi over 12, 11 pi over 6. And then 23 pi over 12. There's your radian circle, also with degrees. A Ferris wheel has 8 cars on it. The height of the Ferris wheel is 120 feet. Part A is to find the height of each car. Part B is to find the height of car 6 after 2 3/4 rotations. Graph the height of a single car as it travels in a circular motion. We haven't set a number of rotations for that graph, so let's just say 4, a minimum of 4 from now on. And this will come back on the screen periodically, so if you want to write that down, you can later on. Alright, here is a circle graph. And we know we have 8 cars. If we have 8 cars on this Ferris wheel, then we have to figure out how to divide these up. So we'll come out here and do 360 divided by 8. So 360 divided by 8 comes out to be 45. So that means starting here, we can make this car 1. And then we have to go 45 degrees in order to get to car 2. And on this graph that we used here, that is 45 degrees. This is car 2. And remember, that is 45 degrees. And then we go to 90 for car 3. And another 45 degrees out here to car 4. And that is 135 degrees. And car 5 is going to be here at 180. Another 45 degrees puts us here for car 6. And that is 225 degrees. We're just adding 45 each time. And then right here is car 7 at 270. And then car 8, if we add 45 more degrees, we get 315. Now, your graph paper could have all kinds of spokes on it, some of which may not be necessary. Sometimes you don't need 90 and 0 and 180 and 270. In this case, we do. But in any case, always go back and draw some spokes. And in my case, I highlight them when I go back and do the homework solution guide so that it doesn't get so confusing. You only see what it is that you need. So what I'm going to do is in blue, go back and make these spokes. We'll thicken up the marker a little bit, and even when I highlight over the axes, it's still useful. Alright, the Ferris wheel has been filled in with degree measurements, car numbers, all kinds of good stuff. I will pick the color of green. Let's see. We'll make it darker green. Alright. How tall is the Ferris wheel? 120 feet. If it's 120 feet, how high up is car 1? 60. Yeah, you just cut it in half. So 60 feet. Alright, we go to car 2. Make a right triangle from that. And recognize that this angle here is 45 degrees. And that you're looking for this measurement, x. Knowing that the radius of this Ferris wheel is 60 feet because that's half of the height of it. The height is the diameter. Half of that is 60 feet. So this hypotenuse is 60. In order to solve for that x value, you have to set up a sine proportion. So sine of 45 degrees equals opposite x over 60 feet. When you type it in your calculator, you want to do sine of 45 first and hit enter. And then multiply by the 60. If you do that, you should come back with an x value of 42.43 feet. That's rounded to 2 places. But that's not the height of car 2. The height of car 2 is found by adding to this number 60 feet, because it's 42.43 feet above 60 feet. When you do that, you come up with a value of 102.43 feet. Of course, the height of car 3 is the easiest. What is that? It's 120, because that's the height of the Ferris wheel. Any questions over anything we've done up to this point? On car 4, if you draw this triangle, you're going to end up with an angle measurement that is between 180 and 135. That means it's 45 degrees. Is there any need to calculate anything for car 4? No, it's going to be the exact same height as car 2. It's even with it. It has the same degree measurement. So we can fill that one in, 102.43. Car 5, is there anything to calculate? No, it's just 60. Car 6, anything to calculate? Technically, yes. If you draw your triangle, you will notice that you will get a 45-degree angle, and this x value will be the same value that you found over here. However, you're not adding it to 60 feet, you're doing what to it? Subtracting. 60 minus 42.43 is 17.57. I think it's 17.57, is that right? Okay. What is the height of car 7? 0. It's not left the starting position. So it's just going to be 0 feet. And is there any need to do a calculation for car 8? No, because it's going to be the same as car 6. So it is 17.57 feet. Part B is up next, and Part B is to find the height of a car, or the height of car 6 after 2 3/4 of a rotation. So here is car 6, and I'll get out my highlighter so we don't wipe out too much stuff. And we'll make this go a little bit thicker. Here's car 6, and I'm going 2 3/4 of a rotation. The circle is broken into how many parts? 8. Yeah, we have 8 blue spokes on there. So every 2 pieces of that pie would be 1/4 of a rotation. So keep that in mind. Here is 1 rotation about that circle. This will be 2 rotations about the circle. Remember, every 2 pie slices is 1/4 of a rotation. So there is 1/4, 2/4, 3/4. What is the height of car 6 after 2 3/4 rotations? 102.43 feet. That's right. Whoa, 102.43. Thick marker. Alright, the last thing to do is to graph the height of a single car as it travels in a circular motion. You can choose whichever car you want to start with. You can choose car 7, car 8, or car 1, but if we just start with car 1, then we can follow it around in numerical order. But if you want to make car 1 the one that's at the very bottom of the Ferris wheel, you can do that too. The graphs will not technically be the same because they won't start in the same spot, but they will still have the same motion and the same dimensions. Okay, so let's go down here, and we agreed that we need to do at least 4 rotations, but we have 8 cars on this, so I don't know if we can fit in 4 rotations. Let's try this. Rotations is at the bottom. There's that thick marker again. I need to lower that. There we go. If I go 1, 2, 3, 4, 5, 6, 7, 8, that would be 1 rotation, and then 1, 2, 3, 4, 5, 6, 7, 8, that would be 2. 1, 2, 3, 4, 5, 6, 7, 8, that would be 3. I don't think I can do 4. So we can slip in 3 rotations. What was the height of the Ferris wheel? 120. So we got to section off this graph so that we can get 120 feet in it. We can count with the laser. I probably need a pointer. I'll use the hand. There we go. 1, oh no, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12. So we could get 120 feet there. Let's see, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We would need 24. So we're better off just going by tens. If we go 1, 2, 3, 4, 5, there's 50. 6, 7, 8, 9, 10, there's 100. And then 11, 12, that's 120. And we can fit in some other things in here. This is an 80. This would be a 30. Something to help us out. Okay, we're going to plot this in red. Hopefully not a highlighter. There we go. And I need my big dots. I can zoom this in a little bit more. Okay, we're starting with car 1. Where does car 1 start at?
$60.
60 feet. So I'm putting a dot, hopefully, on 60. There we go. And after its next movement, its next rotation up into the next car position, what is it? $102.43, so it would be approximately there. What is it now in the next car position? 120. And then in the next car position, is it back to 102.43? Alright, so we'll do that. And then in the next car position, what is it? 60. Next car position? Okay, so that'd be approximately there. And then what is the next car position? 0. And the next car position? Okay, and then we're back to where we started, which should be right there. So there is one rotation. Once you plot one rotation, you should be able to go back and duplicate that like this. Then it goes back down to here, is it? And then down to here, to 0, to here, and then back up to 60. Let's follow it one more time. We're going to come up to here. Whoops, I missed that one a little bit. And then up to here, and back down to here, back to 60, and then down to here. Missed that a little bit. Back to here, then up to 50. So we can go back and draw this. We'll just put it in green. Remember, it's got to be smooth, like this, going to 0 up to 120